algal blooms by analyzing phytoplankton concentrations in open ocean areas across a variety of machine learning models. And predicting the occurrence of these occurrences can inform people in affected areas and reduce their harmful effects.
Yep. So we used data collected off the coast of California that contains a variety of like ocean health signifiers, such as salinity and O2 stat. And then we use these different signifiers to predict chlorophyll, which is a signifier for phytoplankton. So using this clean data, we created a neural net to basically get the best possible prediction for this phytoplankton.
We also fed this data into two models, being the reverse tree and gradient booster. And using these, we were able to map out on a heat map the concentrations of chlorophyll. And using the sliders down here, we're able to adjust it to make predictions. So for example, let's say we really increase the oxygen concentration. That makes it show that chlorophyll is much more common. And it shows the correlation between these parameters and how chlorophyll develops.
All right, so yeah, so I started working on a module where you zoom out of the picture and you start thinking about what ingestion data you're actually working with. So I ended up working with satellite data, looking at some of the ocean conditions. So we have an ocean model, sort of how this the chlorophyll is going across the coast. So I'm on their different sites across different piers, 16 different piers across the California coastline. And this, I compared it to the current standard model that's used within the current landscape of oceanography and being able to detect where these blooms happen. So this sort of objective was to improve the algorithm behind the scenes. And the previous model, this is called CHARM v3, sort of the baseline is a logistic regression model. I improved it through sort of looking at the plots. You have the recall for each sort of section and you have the precision. And across it is our light gradient boosted machine, which was much better across the whole entire board. And yeah.
I can cut it if it's